Hello, everyone. Welcome to the Spotlight Safety December Lunch and Learn series. We're delighted to have you all here with us. Thank you so much for coming. Without further ado, I'd like to introduce our wonderful host this month. This is Kristin Garland. She is our VP of Industrial Hygiene, and she will be speaking to us today about the EPA Methylene Chloride Rule. Take it away, Kristin.
Thank you, Melody, and welcome everyone to this Lunch and Learn. As Melody noted, we're going to be talking today about the new EPA Methylene Chloride Rule. So let's just jump right in. So starting right at the very beginning, what is methylene chloride? It is a colorless volatile solvent that has a sweet odor. The CAS number is 75-09-2. It's also known as dichloromethane or more generally DCM. Industrial uses for methylene chloride include paint stripping and removing. It's used in adhesives and sealants, in metal cleaning and degreasing. It's a really useful solvent, and so it's been used in a lot of different industries and applications throughout its history. It is also used in pharmaceutical research and organic chemistry. So the health hazards of methylene chloride exposure through both dermal and inhalation routes has been pretty well known for quite some time now. Acute effects can include the liver, it can attack the immune system, it definitely affects the nervous system, reproductive system, as well as development, and there can be skin and respiratory irritation as well. Chronic effects, it is listed as an A3 carcinogen through ACGIH, which means that it has been shown to cause cancer in animals. However, the link to human is not as well defined. Also, liver and genotoxicity have been noted. So the methylene chloride regulation, it's regulated under TSCA. It was finalized in May of 2024. There are two parts of TSCA that are regulating this, 6A and 6B. 6B actually requires the prioritization of chemical risk assessments. So it requires the EPA to make a list every year of what chemicals should be evaluated first. And then it is also given the EPA the authority to regulate the use of those chemicals if an unreasonable risk is identified. So this process and timeline is a very basic, watered down, step-by-step how these chemicals are reviewed and assessed. First, they're given prioritization, either high or low priority, and then a risk evaluation is conducted, and either there is an unreasonable risk or no unreasonable risk, and then risk management is implemented to eliminate the unreasonable risk. So the methylene chloride risk assessment that was conducted by the EPA included an assessment of both acute as well as chronic hazards. It included dermal and inhalation routes of exposure, and it was based on the most sensitive endpoint of adverse effects. So basically what they did is said, you know, what is the worst thing and what is affected the most? What is the most sensitive endpoint? And they landed on for acute toxicity, it's neurotoxicity affecting the central nervous system. For chronic non-cancer, there were liver effects, and for chronic cancer, there were lung and liver concerns. And one of the things that I think is interesting about the EPA risk assessment, as opposed to how OSHA and other entities look at risk for these chemicals, is the EPA did not look at a specific population only. So for example, OSHA focuses on healthy adult human, right? People who are working and they tend to be healthier adults. The EPA risk assessment included more vulnerable populations. So it included, you know, potential risks to children, people who have autoimmune diseases, and other high risk sensitivities. So the regulatory actions that were taken, there is a prohibition on manufacturing, import, processing, and distribution that will prohibit the consumer use of methylene chloride by May 5th of next year. So that's right around the corner. Most industrial and commercial uses will be prohibited after April 28th. There are a few exceptions. There is some specific furniture refinishing activities that can go until 2029. And NASA also has some exemption with specific guidelines attached because the aerospace industry would need to basically certify the use of a different chemical if they were to replace methylene chloride. There are 13 use conditions that are allowed through the EPA as long as certain regulatory requirements are followed. SDSs need to be updated by manufacturers by October 7th and processors and distributed by December 4th. So those dates have both passed already and those activities should already have happened. There is also what's called a de minimis threshold that is 0.1% by weight. And that means that any chemical mixture that includes methylene chloride, if the methylene chloride is less than 0.1% by weight, it is exempt from these regulations. So we talked about the different conditions of use. This is a list of the 13 that are allowed through the EPA, and I highlighted use as a laboratory chemical and disposal because those are what I'm assuming from our audience are going to be the most applicable. There is also processing as a reactant, processing and recycling, use as a bonding agent for solvent welding, and a few other specific uses. But methylene chloride moving forward in the United States will only be able to be used legally if it falls under one of these conditions of use. So I noted that there were some requirements that need to be followed if you are using methylene chloride and you fall under one of the 13 use conditions, and that's generally known as a WCPP or a Workplace Chemical Protection Program. And there are really 7 facets to a WCPP. It's instituting new occupational exposure limits. There are some very specific monitoring requirements. There's definition of regulated areas, the institution of exposure control plan, PPE protection, training, and record keeping. So let's start going through that list with the occupational exposure limits. So everyone's heard of the OSHA PEL or the ACGIH TLVs. So this is one that's a little bit newer to the game. It's the EPA Existing Chemical Exposure Limit, or ECEL, and this is an 8-hour time-weighted average, meaning the employee's full 8-hour day is accounted for. So you need the average over the entire day to compare to the ECEL, and that's a 2 part per million exposure. There's also an action level, which is 1 part per million as an 8-hour time-weighted exposure or time-weighted average. And the EPA short-term exposure limit, or STEL, is a 15-minute average. So the reason they do this is the 8-hour average looks at your typical day, but they want to make sure that they're not front-loading a very high exposure right at the beginning of the day and then nothing else and rotating people through. And so that's why we have a 16-minute ppm short-term exposure limit. Now all employees need to make sure that controls are instituted to keep all of their exposures below these OELs by August 1st of 2025. So monitoring requirements, right? How do we know what employees are being exposed to? We can do some monitoring. So all initial monitoring has to be done by May 5th. That's just a couple months away, so definitely mark that on your calendar. The monitoring needs to follow good industrial hygiene protocols. So we want to look at the personal breathing zone. So we don't necessarily want to stick a badge in a room and find out what the room is. We need to be able to equate it to a personal exposure. And we are allowed to group by what's called a SEG, or a similar exposure group. And what that means is if you have 10 employees that pretty much do the same job and really are going to have the same exposure, you can sample 1 or 2 of those employees and then apply the results to the similar exposure group. They need to include the highest likely exposure, both for the full 8-hour day, as well as sampling specifically for that 15 minutes of highest potential exposure. And sometimes that's hard to determine. Sometimes what I'd like to do is do a full day badge and then do a couple 15-minute samples here and there just to make sure we're catching what we need. Any employees need to be notified of the results within 15 working days. That includes all workers in the SEG if you are using representative samples. And then depending on the results, periodic monitoring may be required. If you're above the ECEL and or the STEL, you have to monitor again within 3 months. That means you have to also address that exposure within those 3 months. If you're above the action level, but not necessarily above the full exposure level, it's 6 months. And if you're below everything, you need to monitor every 5 years at a minimum, as well as anytime you have changes in procedures, processes, etc. And you are allowed to document objective data in place of monitoring. So for example, if you're only using it in a closed system, you're only working in a fume hood, you're using very small volumes, the potential for exposure anywhere near any of these occupational exposure limits is just really not feasible. That can be documented, but you want to make sure that you have that really well outlined and in your files. So regulated areas need to be defined if you have some at your facility. So monitoring is really helpful to identify these spaces, and they're defined as areas that could exceed the ECEL and or the STEL at any point during the day for regular use. So this does not necessarily consider a spill, for example. But if there is reasonable anticipation of overexposure to either of these exposure limits, then you want to have a regulated area set up. It needs to be established within 3 months of that initial monitoring or by August 1st, whichever is first. The access needs to be restricted to authorized users. Respiratory protection must be provided if inhalation exposures could exceed any of the occupational exposure limits. Of course, engineering controls are always our first pass, but if for some reason that's not feasible, we do have to move to respiratory protection, and the area needs to be properly marked. Now, the next piece of a WCPP is the exposure control plan, and anyone who works with bloodborne pathogens has heard this term before. And basically the way the EPA outlines it is you are required to work through the hierarchy of controls, which is how most of us evaluate hazards anyway, but you need to document each step as well. So obviously we want to start at the top. Is elimination a possibility? No, it's not. Here's why. Can we substitute a different chemical? I know for some oligosynthesis procedures, you can actually substitute toluene, which just removes the methylene chloride risk, which is obviously a great solution. However, sometimes that's not possible. So you have to document why you can't substitute. What engineering controls are you going to put in? Why are you picking those controls? And then administrative and PPE down the line. When you are looking at engineering controls as your method of control for this chemical, you need to document what your implementation and maintenance requirements are. So if you need to get budgetary approval and then you need to make changes to your HVAC system or whatever needs to happen to institute those controls and to maintain them moving forward, that needs to be included in your ECP. You also need to include a description of any regulated areas, what the markings look like, who is authorized to enter. And that doesn't necessarily have to be a specific list. It can be, users are trained in this group or with this job title, and just have it laid out so that everyone knows who the authorized users are. A description of how the ECP is going to be reviewed, updated, and how management of change will be addressed must also be in your exposure control plan. So respiratory and dermal protection, again, these are the two most likely routes of entry for any kind of methylene chloride exposure. They need to be supplied for anyone who enters a regulated area. So if you are above that 2 ppm, or if it's going to be a 16 ppm overexposure at any 15-minute interval, then obviously we want to go through the exposure controls first and the engineering controls first. And then if you need to use PPE, you need to follow the OSHA respiratory protection standard. You need to ensure that respirators are used when they're required. So you can't, just say we told the employees, we gave it to them and they chose not to use them. You must enforce use of them. They need to be NIOSH approved supplied air respirators or airline respirators only. And the reason for that is there are no air purifying cartridges that are effective for methylene chloride protection. So if you do need to go the route of respiratory protection, it needs to be an airline or supplied air respirator only. And the standard actually very specifically lays out the requirements for whatever the exposure level is anticipated to be, what type of respiratory protection would be appropriate. And this is required by August 1st of 2025 or within 3 months of the monitoring results indicating that your exposures exceed the OEL. Training, like most safety training, should be provided prior to job assignment. It's required for all authorized users who will be entering a regulated area. They try to align it with the methylene chloride standard that is already in place through OSHA, and PPE training must be included. So before you can give someone a respirator and send them into a regulated space, they need to go through the full respiratory protection program as well. Record keeping, you are required to keep your compliance records for at least 5 years, and they must be available for inspection upon request. Any type of monitoring records needs to be a full-on industrial hygiene report. Just having the results in a folder is not going to cut it. You need the sampling dates, the operations described, you need the number of samples, your sampling and analytical methods, what PPE was there, the job classifications, the description of your similar exposure group, and the equipment that you used to collect your monitoring data needs to have serial numbers and calibration dates included in your report as well. So that is the methylene chloride rule in a nutshell. Really what I want everyone to get out of this webinar, the important take-home messages are that the EPA exposure limits are quite low compared to the existing PELs and TLVs. As you can see in this little chart here, from 50 or 25 down to 2, that's an order of magnitude change, as well as for the 8-hour action level from OSHA to EPA, and the 15-minute exposure limit from OSHA to EPA as well. And then important dates to have marked on your calendar. You need that initial monitoring done by May 5th. That's going to come faster than we know it. OELs and PPE need to be addressed by August 1st, and your exposure control plan needs to be in place by October 30th. That is the EPA Methylene Chloride Rule in a nutshell. If anyone has any questions, maybe we can open up the Q&A or the chat.
Thank you so much, Kristin. Yeah, please, if you have any questions for Kristin, please add them to the chat, and she'll be happy to answer those for you. Wait another couple minutes. While people are thinking through questions, Kristin, do you have any other advice for anyone working with methylene chloride? Anything people should
Yeah,
know?
I think, another piece is if you already have a chemical hygiene plan, a lot of the WCPP can be integrated into your existing chemical hygiene plan. At Spotlight, we have the resources to assist you with any part of this program. If you need your monitoring done, if you need an ECP as part of your WCPP, we can help you with that. Any part of your chemical safety program, feel free to reach out and we can assist with that. Otherwise, for general safety, I think another great thing that we offer, and Melody, you might want to talk about this, we have a safety app that we've rolled out recently that I think is pretty fantastic. For all industry, not specifically for laboratories, but I know everyone has issues with tracking people during emergency evacuations, communication channels, and I think we have a pretty good solution for that.
Thank you so much, Kristin. Feel free to reach out if you'd like more information about anything Kristin mentioned or the safety app. We'd be happy to share it with you. We do have a question in the Q&A from, what do you suggest for a lab facility that would use DCM very rarely in order to perform monitoring? For example, would a facility need to emulate that work?
I think there's two ways that we could address that. The first is yes, kind of, doing a mock use of that DCM, I think is something we could do for monitoring. If it's very, very rare and we can demonstrate that it will only be used in a fume hood and there's very little potential for actual exposure, we could take the objective data route and kind of document that the whole process was reviewed, that it's unlikely that you will even approach any of the exposure limits, and that would be acceptable as well.
Thank you so much. We have another question here. How will academic institutions be affected? E.g., since the EPA imposes on my university, how will my EH&S program work with the EPA to regulate our use?
So that's a really good question. I believe that because it's through the EPA, that it would cover the academic institution and you would just have to do the same steps, right? So go through the monitoring. That's going to be difficult if it's being used in a lot of different laboratories and different spaces. But I think that the rule would still apply, and there's no exemption for academic laboratories, as far as I recall. I can double check that, but I think you'll still be required to go through the monitoring, PPE, go through the exposure control plan if you need it as well.
Thank you. We've got one more question here.
Yep.
Will we use liters of DCM at a time? Will the EPA require our lab spaces be fitted with DCM monitors?
So the requirement gives you what your goal is, and however you actually reach that goal, you have some leeway. So they're not going to require you to have DC monitors, placed throughout the laboratory that are talking to you in real time. If you can characterize exposures and control exposures at each different point, I think that will be enough to cover you, but I don't think that they are going to require in-place monitors with alarms or anything like that. Oh, grad students wanting to be safe, thank you. We've been in a lot of academic institutions and it's so much focus on the research. I really appreciate you guys joining us today to understand the safety piece as well. Reach out to us anytime.
Absolutely. Thank you so much.
Perfect.
We will
Silver
use our
shields are great.
Wonderful. Any final questions before we wrap up? Thank you so much, everyone, for coming. Still have a few minutes here. If you have any burning questions you'd like to ask. You are most welcome. Thank you, everyone, for attending. This was a great showing. Oh, we've got one more question, I think, that just popped up here. No? Okay. Oh, we got one more question here. Kristin, what do you think will be the most challenging part of this new regulation for R&D facilities?
That's a good question. I think the most challenging piece will be staying on top of all the DCM use. in these facilities, right? Because the science changes so fast. I think there's going to have to be a lot of really great communication between those in the lab and those in the safety department to make sure that if you can get your full evaluation done, and then if anything changes, you need to be notified right away so that the program can adjust. That's where I think it's going to go.
Wonderful. Thank you so much, Kristin, for your time.
Mel,
Anyone
there
who's
was a
attended,
question about the
oh,
recording, if the recorded video will be available.
we are working to make it publicly available, yes, and we can let you all know when that is available. Yep, thank you and so feel free to share it with anyone who wasn't able to attend today. Thank you all for being here. Thank you, Kristin, for sharing your expertise with everybody. And we do have this series as a monthly recurring series for different subjects on safety and industrial hygiene. So grateful you all could join us, and we hope to see you back next time.
Yes, thank you all. We appreciate it.
Have a great rest of your day.
Take care.